So let's look at question number 1. So question number 1 says, Palvender breeds Labrador puppies at his farm. Over many years, he recorded the weight in grams of the puppies. The data is illustrated in the following box and whisker diagram. So they want us to write down the median weight of the puppy. So we should automatically know that the median is always the line that is in the middle of the box and whisker plot. So here my median falls here, and that is halfway between 200 and 220. So I know that my answer to part A is 210. Remember, you have to write your answers in the box. So for part A, the median is equal to 210. All right. For part B, it is asking, write down the upper quartile. Your upper quartile is the upper bound of the box part of your box and whisker. So my upper quartile is here, and we know that that is 240. Next, they want us to figure out the inner quartile range. We should know that the IQR, the inner quartile range, is the difference between the upper quartile and the lower quartile. We already know what the upper quartile is, so the lower quartile is going to be the lower part of the box, which is at 190. So here I know that my IQR is equal to 240, subtract 190, and 240 minus 190 is 50. All right. So I'm going to make sure I box and highlight all of my answers so that it will be easy for them to find. And last but not least, it says, find the weight of the heaviest possible puppy that is not an outlier. So the qualifications to be an outlier are numbers that are smaller. So an outlier is going to be any number that is less than your Q1 minus 1.5 times the IQR, or your outlier can be any number that is greater than your Q3 plus 1.5 times the IQR. All right, so because it says that we're looking for the heaviest possible puppy, I'm looking for the bigger outlier, which means I need to focus on this piece here. So in order for me to find out what the heaviest possible weight is, or what the biggest weight that it can be before the number or before the weight becomes an outlier, I would just have to say that I have my Q3, which is 240, plus 1.5 times my IQR, which is 50. So if I do 240 plus 1.5 times 50, I will end up getting 315. So that's the biggest possible weight. Anything above 315 is going to be an outlier. All right, so that's question number 1. Question number 2. It says we have the Osaka Tires. Osaka Tires basketball team plays in a multi-level stadium. The most expensive tickets are in the first row. The ticket price in yen for each row forms an arithmetic sequence. Prices for the first 3 rows are shown in the following table. Write down the value of the common difference. Remember, the common difference is how your values are changing from one number to the next. So as we can see here, our common difference, if I look from 6,800 to 6,550 to 6,300, I can see that I'm going down by 250. And you can also find that by doing your next, subtract your previous, And I see that my difference is negative 250 because it's going down. 6,300 minus 6,550 is also negative 250, so that's my common difference there. So for A, your common difference is negative 250. All right. So B, it says calculate the price of a ticket in the 16th row. So we know that here we're going to use our formula U sub n is equal to U sub 1 plus n minus 1 times the common difference. So if I want to find U sub 16, I'm going to have U sub 16 is equal to U sub 1, which is going to be 6,800 plus 16 minus 1 times the common difference, negative 250. So when I type that in into my calculator, I end up getting that this is going to be 3,050. All right, so that is the price of a ticket that's in the 16th row. So for part C, it says, find the total cost of buying 2 tickets in each of the first 16 rows. So the first thing I need to do is I need to find the sum of the tickets in the 16th row, and my sum equation that I am going to use is S of n is equal to n divided by 2 times U sub 1 plus U sub n. And the reason why I'm using this one and not the other one is because they're telling me that I need to focus on the first 16 rows, and I already have the price of the 16th row. So I have my U sub n. So if I want to find out the price or the sum of the tickets, I'm going to have S of 16 is equal to 16 divided by 2 times U sub 1 plus U sub n, which is 3,050. All right. So when I do that, I'm going to know that that is 8 times 6,800 plus 3,050. So I end up getting 78,800. Now you have to make sure you understand that it says the cost of buying 2 tickets in each row. So what I actually need to do is I need to multiply 78,800. I need to multiply by 2 because that was the sum of buying 1 ticket in the first 16 rows. So in order to buy 2 tickets in the first 16 rows, if I multiply that by 2, I will end up getting 157,600. All right, so that is my answer there. All right, so now let's look at number 3. So number 3 says, at the end of a school day, the headmaster conducted a survey asking students in how many classes they had used the internet. The data is going to be shown in the following table. So it says, state whether the data is discrete or continuous. So remember, discrete data is data that can only take on a certain value. Continuous data is going to be data that can take on any value within the given range of values that they are specifying. So because they are saying they're conducting a survey on and having the students report how many classes, I already know that I can't have part of a class. I can have 0, 1, 2, 3, 4 whole numbers basically. So I know that A is going to be discrete. All right. Part B, it says the mean number of classes in which a student used the internet is 2. Find the value of K. So we should know that in order to find the mean, we are going to add up all of our numbers and then divide them by the total amount of numbers that we have. So you see that I have a table here. So I have like the number of students in classes which the student used the internet, and then the number of students, or AKA the frequency. So there are 20 students who say they use the internet in no classes, 24 students who say they use the internet in one class, 30 students who say they use the internet in two classes, K students say they use the internet in three classes, 10 students say they use it in four classes, three of them use it in five classes, and then one student uses it in six classes. So we have to write the formula out for the mean. So remember, the frequency or the number of students is giving me the amount of times that the number of classes is written out in a list. So in order to write my equation for my mean, I'm going to have the product of the number of classes and the number of students divided by the total amount of students that I have. Or the sum of the products of the classes and the number of students divided by the total number of students. So here I'm going to have 0 times 20, which is just 0. Then I'm going to have 1 times 24, which is just 24. So I can write 24. Then I'm going to have 2 times 30, which is 60. So I'm going to add 60. Then I'm going to have 3 times k, which is just 3k. Add that. Plus 4 times 10, which is 40. Plus 5 times 3, which is 15. Plus 6 times 1, which is 6. And all of this is going to be divided by the sum of my or my total number. So if I add 20 plus 24 plus 30 plus 10 plus 3 plus 1, those are my students. So I have 88 plus K students here. And I know that this should be equal to 2 because they said my mean was equal to 2 here. So if I want to find the value of K, I need to simplify the numerator. So I'm going to have 24 plus 60 plus 40 plus 15 plus 6. That's going to give me 145. So here I'm going to have 145 plus 3K divided by 88K, or 88 plus K, excuse me, is equal to 2. I'm going to multiply both sides by 88 plus K, so I will end up getting 145 plus 3K is equal to 2 times 88 plus K. So when I do that, I will end up getting 145 plus 3K is equal to 88 times 2, which is 176, plus 2K. And then I need to get all of my K's on one side. So if I subtract 2K, I'm going to end up getting K is equal to, and then I do 176 minus 145, and I end up getting 31 here. So I get 31. So K is equal to 31 here. So part C, it says, it was not possible to ask every person in the school, so the headmaster arranged the student names in alphabetical order and then asked every 10th person on a list to fill out the survey. So part C wants us to identify the sampling technique that is used, and because they have decided to use or ask every 10th person to complete the survey, I know that the type of sampling technique that was used was going to be a systematic, because there was a system to it. So they started off and then they wanted every 10th person. So it wasn't random or anything like that. They knew that every 10th person that was on the list, and they put it in alphabetical order, was going to fill out that survey. So that is question number 3. And remember, make sure you box or highlight your answers to make them stand out to the moderator. All right. So next, let's look at number 4. All right, so question number 4 states that the perimeter of a given square P can be represented by the function P of A is equal to 4 times the square root of A for all A greater than or equal to 0. It says A is the area of the square. The graph of the function P is shown for the values of A being in between 0 and 25 inclusive. All right. So the first thing that they want us to do is they want us to write down the value of P of 25. Well, we already know that the formula or the equation for P of A is that P of A is equal to 4 times the square root of A here. All right, so we got that from the beginning. So now if they want us to find P of 25, we know that we're going to substitute 25 in. So P of 25 is going to be equal to 4 times the square root of 25. We should know that the square root of 25 is 5, and 4 times 5 is 20. All right, so that's the answer to part A. For part B, it says the range or the possible y values of P of A is going to be from 0 to some value of n inclusive. Well, if we already know that the domain goes from 0 to 25, then to find my range or the upper value of my range, I need to use the upper value of my domain. The upper value of my domain is 25, which means that if I substitute in 25 or use my answer from part A, I will end up having that the value of my n is also 20. Okay, so I know that n has to be 20 here. So once I find that, then I can move on to part C. Okay, so part C, they say on the axis above, they want us to draw the inverse. Okay, so we should know that an inverse function has to be symmetrical about the function y is equal to x, or in this case, p is equal to a. And I also have to invert my x and y values. So what I'm going to do is I'm going to just look at a couple points and I'm going to invert my x and y values here. So I see that I have this point here that is going to be at 4, 8 because I'm going by 2's on my x-axis and I'm going by 2's on my y-axis, or my 2's on my a-axis and then 2's on my p-axis. All right, so this point that I just plotted here is going to be located at 4, 8. So I know that, remember, when I write the inverse, I basically swap my x and y. So instead of my point being at 4, 8, it's going to be at 8, 4. So the point that I need to draw is going to be at 8, 4. If I have another point that is at, let's do 16, because 16 is an easy number to take the square root of. So if we do 16 here, that's another pretty point. And we know if we do 16, we know that when we swap 16, that's what it's going to be. And then we already know that the last point here was going to be at 25, 20. So the opposite of having 25, 20, or the inverse of 25, 20 is going to be 20, 25. So if I go to 20, 25, that's 22, 24, halfway is 25. So here is my point here. So I know that my graph that is going to be drawn is actually going to be, and I know that we're going to still start at 0, 0. It's going to look something like this. And it doesn't have to be perfect. Just make sure if you specify the points, they can tell where it goes through. So the part on the graph that you needed to have drawn was the part in red and the points that are in blue in order to get credit. Part D, it says, in the context of the question, explain the meaning of the inverse of P of 8 is equal to 4. All right, so remember, we already know that the definition of inverse means that you are basically swapping the x and the y. So when we do part D, we have to explain it in terms of what we are meaning or what we are talking about. So we already remember that A stands for the area of the square, P is going to be the perimeter of the square. So if I say the inverse of P of 8 is equal to 4, then we need to remember that when we had our equation, it was P of A, okay? So we used to have that our independent was A and our dependent was P. So now it's going to swap, okay? So if I had P of 8 is equal to 4, that would mean that my area is 8 and my perimeter was 4. However, when I do the inverse, that means that I am switching what my meanings are. So my inverse basically means that I can say here when the perimeter is 8, because remember we're swapping the meanings. When the perimeter is 8, the area is 4. All right, so that is my answers for number 4. All right, so now let's move on to number 5. Number 5 states that Professor Vinculum investigated the migration season of the bulbul bird from their natural wetlands to a warmer climate. He found that during the migration season, their population could be modeled by the equation. P is equal to 1350 plus 400 times 1.25 to the power of negative t. And it's for the values of t greater than or equal to 0 because t represents the number of days since the start of the migration season. So it says here to find the population of the bulbul birds, number 1, at the start of the migration season. So remember, we should understand that the word start means y-intercept, and the value of your y-intercept is the value of y when x is 0. So the start of the migration season is telling me that t is equal to 0. So I'm going to have P is equal to 1350 plus 400 times 1.25 to the power of negative t, or negative 0. That's just 0. And we know that anything to the power of 0 is 1. So this is just 1350 plus 400 times 1.25 to the power of 0. And that will be 1750. All right, so that's the initial population. All right. It tells us that we also want to find part 2. And part 2 is saying what is the population in the wetlands after 5 days. So if I want to find my population after 5 days, I do the same thing, except I just substitute in 5. So we're going to have P is equal to 1350 plus 400 times 1.25 to the power of 5. And when we do that, I will end up getting approximately, and it says we have bulbul birds, so make sure you understand that we have to give our answer, and it should be a negative 5, excuse me. We have to give our answer to the nearest bird, okay? So that will end up giving us that we will have approximately 1481. If you wanted to put your answer in 3 significant figures, they would accept 3 significant figures as well. And your answer in 3 sig fig would have been 1480 in 3 significant figures. So either or would have been the correct answer there. Now for part B, it says calculate the time taken for the population to decrease below 1400. So if we want to find the time taken for the population to decrease below 1400, we're basically trying to solve the equation of where it is equal to, because we know once it equals 1400, it is going to go below that mark. So here we're going to say that we want 1400 equal to 1350 plus 400 times 1.25. We don't know what t is, so that's still going to be negative t. So once we do that, we can go to y equals. We can put our left side of our equation in y1 and put the right side of our equation in y2. Once we do that, we are going to graph it, and we may have to adjust our windows, we may not. And instead of negative t, I'm going to use the negative x there. So once we graph it, we're going to see if we see any part of the graph. Remember that wheel, as that wheel in the top right hand corner is spinning by the battery symbol on your calculator, you know it's still thinking and it's still trying to compute. So now it's stopped. I don't see anything, so I'm going to press zoom, and I'm going to go to zoom fit so I can fit it to the screen so that I can see something, because I don't know where my graph is going to land at. So I see one part of my graph there, and then I see the other part of my graph here. So I know that by this part of my graph, I'm going to be able to zoom out so I can see a little bit more. So I'm going to press zoom out. And before I press enter, I'm going to scroll down a little bit because I want to zoom out in a certain area. So I'm going to scroll down just a little, and then I'm going to press enter. All right, and once I do that, I end up getting the following graph. And hopefully it should be easier for me to see what's going on here. So as you can see here, I see about how long it's going to take for that to start going below. So I'm going to press second trace, and I'm going to locate the intersection. I know that the intersection is somewhere right in here because I see where the colors are above and below each other. Once I find my intersection, this is what I get here. So basically, I know that for them to actually be the same, it's going to be 9.31, or you can write out the full answer if you want. But I'm going to just write it in 3 significant figures. So I know that by this graph, I know that it's going to take approximately 9.32 days for it to be below. Okay, so that is going to be my answer here. All right, last question. It says, part C, it says, according to this model, find the smallest possible population of the bulbul birds during the migration season. So if I say the smallest possible population, I am basically asking, what is my asymptote? Okay, what is my asymptote? Meaning, what value is my y values getting closer to? So if I look here and I go to my table, remember your asymptote is the value that your function gets very, very, very close to, but does not touch. So I'm going to go to y equals, and I'm going to delete out y1 because I don't need it, and I'm going to go back to the table, and I am looking for the value that my population gets closest to as my x values keep increasing or the days keep going by. So as you can see here, as I scroll on the table, I see that the lowest amount that my values are getting to, it seems like they're getting very, 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 very close to 1350. And as you can see, when you actually click on the actual y values, it's not 1350 exactly, it's just close to 1350. All right, so that is my asymptote because that's going to be the smallest population there. So you just look in the table for that. All right, so that is number 5. Now let's look at number 6. Number 6, it says, as a part of a study into healthy lifestyles, it says Jing visited Surrey Hills University. Jing recorded a person's position in the university and how frequently they ate a salad. The results are shown in the table. So it says he conducts a chi-square test for independence at a 5% level of significance. So they want us to state the null hypothesis. So remember, anytime you have a null hypothesis in a chi-square test for independence, we are saying that the two variables are independent of each other. So for part A, you could say that the number of salads per week is independent of a person's position at the university. Now, if you wanted to, instead of you saying that is independent, you could say it has no association or it's not associated. They will accept the word not associated. All right, so that is the null hypothesis. Of course, the alternative hypothesis would be that the number of salads per week is dependent of a person's position in the university or is associated with. All right, so that will be the alternative if they ask for it. So part B, it says calculate the p-value of the test. You have to use the calculator for this. You cannot do it by hand. So anytime we want to do a chi-square test for independence, I have like a table, and it's actually like a multi-row and a multi-column two-way table. So I need to put this in as a matrix. So I go to second matrix, and I go over to edit, and I'm going to edit matrix A. And as you can see here, I have 3 rows, 4 columns. So I'm going to enter in all of my numbers here. All right, so now that I have all of my numbers here, I can go back. So I can press second quit. And then I'm going to go to stat, go over to test, and I'm going to go down to chi-square test because in the calculator, test for independence is the regular chi-square test. So when I go to C, I press enter. I know that my observed data, which is the actual data that's given to us, is in A. I know that it's going to put my expected data in B. So now I want to calculate everything. So once I press calculate, the p-value, as you can see here, is going to be approximately 0.0201 in 3 significant figures, or you can write that whole number out. All right. So now part C, it wants us to give it says state giving a reason whether the null hypothesis should be accepted. So remember, you should understand that if your p-value is less than the significance level, okay, you are going to, if your p-value is less than the significance level, you are going to reject the null hypothesis. All right, so you may need to write that as a little point somewhere. So we're going to have p is less than significance level, and we're going to have reject the null hypothesis. All right, and we also know that you need to reject the null hypothesis if your chi-square calculation is greater than your chi-square critical. All right, so we're focusing on the p-value and the significance level though. So as we can see here, we see that our p-value 0.0201 is less than the significance level as a decimal, which is 0.05. So from there, we can say that we are going to reject the null hypothesis. H sub 0 represents the null, so we're going to reject the null. If you don't want to write H sub 0, you can actually just write the null. Okay, so we're going to reject it. So that is my answers here for number 6. And it says state with giving a reason. So you have to give the reason here that this value is less than this value. You have to put that in there. All right. If not, they're not going to give you full credit. All right. Number 7. It says we have the following 5 points, and they represent snow shelters in Blackburn National Forest. These snow shelters are illustrated in the following using the following coordinate axis. We know that on a horizontal scale, 1 unit represents 1 kilometer, and a vertical scale, 1 unit also represents 1 kilometer. Calculate the gradient of line segment AE. So for line segment AE, I see that A is going to be located at 3,1. And I see that E is located at 7,3. So 3,1 and 7,3. So if I want to find the gradient for part A, I know that my gradient between my 2 points would actually end up being found by having M is equal to 3 minus 1 over, let me write this so you can see it. So it's going to be 3 minus 1 divided by 7 minus 3, and I end up getting 2 over 4. You can leave it like that, or you can simplify it to 1/2. All right, so that's the gradient of AE. So the next part, it says, the park ranger draws 3 straight lines to form an incomplete Voronoi diagram. Part B wants us to find the equation of the line, which would complete the Voronoi cell containing site E. We want to complete the Voronoi diagram containing site E. It says they want us to give our answer in the form of AX plus BY plus D is equal to 0, where A, B, and D are all integers. All right. So if they want us to complete the Voronoi diagram containing site E, what we need to do is we need to look between A and E, and we need to see what the what the midpoint is between A and E. Okay, because they said they want us to complete the Voronoi diagram or the cell for part or for site E. So if I focus on site E here, I need to have a line that's going to be going perpendicular somewhere like this. All right, so that means that I need to find my midpoint. So for my midpoint, between AE, my midpoint will end up being my X value. So I'm going to have 3 plus 7 divided by 2. And then I'm going to have 1 plus 3 divided by 2. Add your X values together, divided by 2. Add your Y values together, divided by 2. So as you can see here, my midpoint is 3 plus 7 divided by 2, which is going to give me 5. My Y value of my midpoint is 1 plus 3, which is 4, divided by 2, which is 2. So that's my midpoint, 5, 2. So not only does my midpoint have to be at 5, 2, but my slope needs to be the perpendicular bisector. So I know that the perpendicular gradient of AE is going to be equal to the opposite reciprocal of the actual slope or gradient between AE. The original slope was 1/2, so I know that perpendicular is going to be -2. So now that I have my midpoint and my gradient, I can now substitute this into point slope form and then find my equation of my line. So I'm going to have y subtract 2 is equal to my slope times x subtract 5. I'm going to distribute, so I end up getting y minus 2 is equal to -2x plus 10, and then I'm going to get everything on one side. It doesn't matter whether you get everything on the left or the right, it does not matter. We would have that everything is equal to, and I'm going to take everything over to the left, so that's going to be a positive 2x plus y, and then I have to subtract 10, so that's going to be -2 minus 10 is -12 is equal to 0. If you wanted to, you could have taken everything over to the right-hand side and you would have gotten -2x minus y plus 12 equals 0. Either or, you would have been correct. All you did was take one equation and multiply everything by -1 and switch the signs of everything. They are the same. All right, so either or would have been your answer. All right, now for part C, okay, so for part C, they want us to explain the significance, okay, they want us to explain the significance of the Voronoi cell containing site E. So you have to remember that we are referring to and we're talking about the snow shelters at the forest, all right? So we could basically say that for the Voronoi diagram containing site E, we could say that every point in that cell in site is going to be closer to site E than any other snow shelter, right? And let me just move this a little bit so that I can have room to write my part C. So I can say every point in the cell is closer to, we can call it shelter E. So that is what answer choice, what the answer for C is. All right, so now let's look at number 8. For number 8, it says the intensity level of sound, L measured in decibels, is a function of the sound intensity, which is represented by S. That's going to be measured in square meters. So, or watts per square meters. It says the intensity level is given by the formula. So we have that the L is equal to 10 times the log base 10 of S times 10 to the power 12. And we're saying that the sound intensity has to be greater than or equal to 0. So for part A, it says an orchestra has a sound intensity of 6.4 times 10 to the power -3 watts per meter squared. And then it says we want to calculate the intensity level, or L, of the orchestra. So that means all I'm doing is substituting this value in. All right, so when I do that, I will end up having that L is equal to 10 times the log, and I know base 10 is just a regular log, but if you want to, you can put the 10. And then we're going to have our S. So that's going to be 6.4 times 10 to the power -3. And then we can't forget the times 10 to the power of 12. All right. So when we do that, we can literally put that in the calculator. So we're going to have 10 times the log of 6.4 times 10 to the power of -3 times 10 to the power of 12 And we will end up getting, and of course I'm going to put my answer in 3C Fig, we're going to end up getting 98.1. Okay, and we know that we're doing this in decibels, so we can put decibels there. So that is my answer for part A. Part B, it says a rock concert has an intensity level of 112 decibels. Find the sound intensity. So if I know that my intensity level is 112, then that means I substitute that in for L. So the equation that I need to solve is going to be 112 is equal to 10 times log base 10 of S times 10 to the power of 12. All right, so I'm going to put the left side on Y1, and then I'm going to put the right side in Y2. So that's going to be 10 times the log of, instead of X, S, we're going to put X. So this is going to be X times 10 to the power of 12. And then we're going to graph it. All right. So as you can see here, we graphed it, but I really can't see anything here. So I'm going to press zoom. And I'm going to press zoom 6 to take me back to how my graph normally looks, zoom standard. Because I did zoom standard and nothing is showing up, then I'm going to hit zoom 0 to fit it to the screen so that I can see clearly what's going on. So I can see that they cross somewhere near the bottom, so I'm going to press second trace and I'm going to go to number 5, intersect, and I'm going to get as close to that intersection as possible. So I'm going to be somewhere like here, and I'm going to press enter 3 times, and I end up getting that my intersection is 0.158 in 3C Fig. So I know that here. Remember, we're looking at X because S in the original equation was X in Y equals. So here we're going to have that S is approximately 0.158. And that is the sound intensity. And of course, it's going to be measured in watts per meters squared. Okay. So that is my answer here. All right. So now let's move on to number 9. So number 9, it says, Miss Calhoun measures the heights of students in her math class. She's interested to see if the mean height of male students, M sub 1 or mu sub 1, is going to be the same as the mean height of female students, mu sub 2. The following information is recorded in the table. All right. So it says that at the 10% level of significance, a t-test was used to compare the means of the two groups. The data is assumed to be normally distributed, and the standard deviations are equal between the two groups. So for part A, question 1, it says that they want us to state the null hypothesis. So the null hypothesis is that there is no difference between the means. All right. So my null hypothesis is going to be is that mu1 is going to be equal to mu2. Next, they want us to state the alternative hypothesis, basically the opposite of it. So remember, it says that she's interested in seeing if the mean height of male students is the same, okay, as the mean height of the female students. So we're trying to figure out if the means of the heights are the same or if they're different, okay? So when I say that they are different, I'm saying that they're just not equal to each other. You don't have to worry about less than or greater than. It will tell you if you're looking at less than or greater than in the problem. I just want to see if they are not equal to that, okay? So if I have this as my null and my alternative, then I know that because my difference, if I convert this to me saying about my difference, then I know that I could rewrite these, and my null will be that my difference is 0. So that means when I subtract mu sub 1 and mu sub 2, my difference is 0. If I say that the means are not equal to each other, then I'm saying that the difference between the two is not equal to 0. Okay, so these are my null and my alternative hypothesis here. All right. So now for part B, it says we want to calculate the p-value for the test. So what I'm going to do is I'm going to go to Stat, Edit. I'm going to put the male heights in L1. And I'm going to put the female heights in L2. Remember, be careful and make sure you're double checking as you're typing in your numbers. All right, so now once we do that, we're going to go to Stat. We're going to go over to Test. And we are doing a two sample t-test because we have two things that we are going to compare, male and female. So I'm going to go to two sample t-test number 4. I know that my first list goes in, and I'm going to put that it goes based off my data. Remember, you can do data or stats. We're not doing stats because they didn't tell us the information. We're putting in our data. We know that our list 1 came from L1, our list 2 came from L2. We already know that the frequencies are 1. And then it's telling us that we want to figure out what our alternative hypothesis is. So our alternative hypothesis is that M sub 1 is not going to be equal to M sub 2. Going back to my my null and my alternative hypothesis, if you wanted to write your answer and leave it like what we wrote first, you can leave it like this. The moderators know that these equations are equivalent. So this equation is the same thing as this equation. You just got everything on one side. This equation is the same thing as this equation. They understand that. So either or, you would have been good as far as your hypothesis. Okay, and it probably will save you time just to write it like the one that is there previously when we started. So I just wanted to show you how you can write both of them. So B says calculate the p-value. So we made sure that we have M sub 1 is not equal to mu sub 2. So then we're going to make sure that we also go down to that is pooled. We always deal with pooled t-tests, always. So once we do that, we're going to go down to calculate, and then we can see our p-value there. So we can see that our p-value is approximately 0.296, okay, and 3 significant figures. And then for part C is saying that we need to state, given a reason, whether she should accept the null hypothesis or not. So remember, when we're given a reason, we are comparing the p-value to the significance level. So we already know that 0.296 is going to be greater than 0.10. So remember, if the p is low, we reject the whole. Remember, anytime we say h sub 0, that's why I'm saying whole, and we already know that this is the null. All right, so if your p is low, reject the whole. So my p is not low, my p is actually higher in this case. So we do not reject the null hypothesis. And we can say, if we don't reject the null hypothesis, we know that we're going to accept it, which means that there is no difference between the two means. All right, so we're going to accept the null. And then we're going to hit, there is no difference between the means. And I'm going to say of male and female. All right. So that is the answer to number 9. Okay, or those are the answers to number 9. Number 10, it says the following diagram shows part of the graph, which is going to be at f of x is equal to 6 minus 3x times 4 plus x, where the values of x are all real numbers. The shaded region R is bounded by the x-axis, the y-axis, and the graph of f. So part A says write down an integral for the area region for R. So anytime they want us to write down integral, that means they want us to define what our limits are for the shaded region. Well, we already know that this is a quadratic function, and if we don't know, you can easily look at the graph and tell that it's a quadratic function, or if you wanted to, you could just graph it. So I'm going to go on Y1, and I'm going to press parentheses 6 minus 3x, close the parentheses, open up a new set, and that's going to be 4 plus x. So when I do that, I'm going to graph it, and I'm going to see what I get here. So anytime they want me to write an integral, let me press zoom 6 so I can see everything I need. So because they want me to write an integral, I need to figure out what the values of my x values are of the shaded region. So I already know that this x value here is 0. The question that I need to answer is, what is this x value here? So if I see it on my graph on the calculator, I'm going to press second trace, and I'm going to press 0 for x-intercept, and it's telling me to pick a number on the left side. So it looks like that x value is going to cross somewhere in between 1 and 3. So I'm going to put 1 as my lower bound, and I'm going to put 3 as my upper bound. And I see that when those two bars show up, I see that the x-intercept, or the 0 that's in between them, is what I need. And I see that that is 2. So that's going from 0 to 2. So now they say for part A, write down the integral for the area. I already know that I'm going to have for part A that I can say that the integral from 0 to 2, and that's going to be of 6 minus 3x times 4 plus x. And of course, we have to put with respect to x. So we need the dx, okay? So that will be part A. All right, part B, it says find the area of the region. So now that they want us to find the area of the region, we can just use the calculator for it. So you can do this one or two ways. You can go to second, trace, and if you want to, you can go down to number 7, because that's the integral. It's telling us to put our lower limit, so we know that our lower limit is 0, and we know that our upper limit of it is 2. And as you can see, it actually shades it, and it tells us that our area under the curve is 28 at the bottom. If you didn't want to do it like that, you can go to the main screen and do math, and then go down to number 9, your function integral, and then you could have literally typed it in exactly how it was written. So that's going to be parentheses 6 minus 3x, close the parentheses, open up another one, 4 plus x. Close it, and then we know we're doing with respect to x. You could have still gotten 28. All right? So either or, you would have been fine, no matter which method you chose. So for part C, it says we need to find the value A of the x coordinate of C such that the area of the triangle is equal to the area of the region. All right? So they gave us some information here. They said that there are 3 points, and these 3 points are going to be located at 0, 0, 3, 10, and then we're going to have a 0 here. So we want to find the value of A. All right, so in order to find the value of A, we have to see we have to use the area formula. So we know that the area of a triangle is going to be equal to 1/2 times the base times the height. All right. So we know that the area says the area is going to be equal to the area of the region R. So we already know that the area is going to be 28. So that's going to be 28 equals to 1/2 times the base. The base is how long the bottom part is. So basically, I'm going from 0 to A. So basically, the difference between 0 to A is A. So that A is going to be my base here. So that's going to be times A times the height. And the height is going to be how high it goes, which is 10. So I'm going to end up having that 28 is equal to 5 times A. And then, of course, that will end up giving me that A is just equal to 28 over 5. If you want to put it as a decimal, you can. You can say, or that is equal to 5.6. Either or, that's fine. Fraction or not fraction, doesn't make a difference. So either one of these will have been my answer here. All right, so those are my answers. So now let's go to number 11. So number 11, it says, Helen is building a cabin using cylindrical logs of length 2.4 meters and a radius of 8.4 centimeters. A wedge is cut from one log, and the cross-section of this log is illustrated in the following diagram. It says we want to find the volume of this log. Well, in order to find the volume of the log, you have to understand what kind of shape you're dealing with. If the log was complete and the wedge was not cut out, it would have been a cylinder. All right. So we should understand that the way that we find the volume of a cylinder is that you're going to have the area of the base times the height. So, and that's for anything where the cross sections are the same. And when I say cross sections, I'm saying that you don't come to like a point. I'm saying that this is going to be the same width as this is going to have the same width everywhere. All right. So I already know if my formula is going to be equal to the area of the base times the height. If I find the volume of the entire log here, I'm going to have the volume is going to be equal to the area of my base. So the area of my base is going to end up being the area of the circle. So that's going to be equal to pi r squared. So that's going to be pi times 8.4 squared. But remember, it's not the full circle. We have to subtract that sector that's in there. So we're going to have to do minus the area of the sector, which is going to be 50 degrees over 360 times pi r squared. So that's the area of my base. I take the area of the whole thing minus the piece I don't want. And then I have to multiply that by the height. Well, one thing you should understand here is that my radius is in centimeters, but my log or my length of my log is going to be in meters. So I have to either convert everything to meters or everything to centimeters. If they do not specify, that is fine. All right. Normally, the way we do it is we normally convert our larger unit to the smaller unit. So normally we convert from meters to centimeters. So if that was the case, we should know automatically that there are 100 centimeters in 1 meter. So if I have 2.4 meters, that's going to give me 240 centimeters. So that's what I need to multiply as my height. So I'm going to have that multiplied by 240. So literally all I have to do is substitute that into the calculator as it's written. And then we're going to multiply that by 240. And we end up getting that our volume of our log is approximately 45, 800 in 3 sig fig. Remember, I'm putting my answer in 3 sig fig. You can either do 3 sig fig or you can write the entire answer all out. Okay, so that is going to be our volume, and we already know that this is going to be in centimeters cubed here. All right, so now let's look at number 12. Number 12, it says, He plays a game involving a biased six-sided die. The faces of the die are labeled -3, -1, 0, 1, 2, and 5. The score for the game X is the number which lands face up after the die is rolled. The following table shows the probability distribution for X. So it says find the exact value for P. So one thing you should remember is anytime you have your probabilities, you should understand that the sum of your probabilities should equal 1. All right. So I can say that the sum of all of my probabilities should equal 1 here. So because my probability should equal 1, I know that when I add up all these numbers, I should get 1. So here I'm going to have that I have 1 over 18 plus 3 over 18 plus 1 over 18 plus 2 over 18 plus 7 over 18. That equals 7 over 9. So I know that my sum should end up being 7 over 9 plus P is equal to 1. So I already know if I subtract 7 over 9 on both sides, 1 minus 7 over 9 is 2 over 9. If you got 4 over 18, that is still an equivalent form. Okay? So that is what P is. So now I go to part B. Part B says, He plays the game once. Calculate the expected score. So remember, the expected score is basically the average of what you expect to happen. So basically, all you have to do to find your expected scores, and remember your expected score, so E of X is just equal to all of your, the sum of all of your probabilities added together along with the actual value or the score. So remember, your expected score is nothing but the sum of all the X values times the probabilities of those X values. So if I were to do that, all I would need to do is take -3, multiply by 1 over 18, and add it to -1 times the probability that you would get that, which is going to be 2 over 9, plus we already know 0 times 3 over 18 is 0, so we don't have to type that in, plus 1 times 1 over 18, which we know is just 1 over 18, plus 2 times 2 over 18, plus 5 times 7 over 18. So our expected value is approximately in 3 sig fig 1.83. So that's our expected value. All right, so next for part C, it says He plays the game twice and adds the two scores together. What is the probability that He has a score of -3 total? So that means between the first roll and the second roll, you want a probability of -3. The only way that you can get a probability of -3 is if you find the probability of getting a -3 and a 0, or the probability of getting a 0 and then a -3. So remember, anytime we have the word and, we multiply. If we have the word or the symbol or, we add. So this is going to be equal to the probability of getting 1/3 is 1 over 18. And that means multiply. We're going to have the probability of getting a 0, which is 3 over 18. Or add the probability of getting a 0, which is 3 over 18. And the probability of getting a -3, which is 1 over 18. So in other words, this is just basically 2 times 1 over 18 times 3 over 18, because they are the same thing. They're just in reverse order, and we already know that multiplication is commutative. All right, so if I have 2 times 1 over 18 times 3 over 18, I end up getting, and if I want to put it exactly, I can put it as a fraction. So I'm going to hit math, enter. That'll be 1 over 54. Or like I said, if you want to put it as a decimal, that would have been 0.0185 in 3 seed fig. So either one you could have given. Either or would have been fine as your answer. All right. So now let's look at number 13. So number 13, it says, Mr. Burke teaches a math class with 15 students. In his class, there are 6 female students and 9 male students. Each day, Mr. Burke randomly chooses one student to answer a homework question. Find the probability that on any given day, Mr. Burke chooses a female student to answer a question. So on any day, he chooses a female student. It says he has 6 females, 9 males. There are 6 females. You have to understand that there are 6 females and 9 males. That's going to be 15 students total. So that's going to be a probability of 6 over 15. If you want to put it as a decimal, you could. It does not matter which is, or you could say 0.4. All right. If you wanted to give it as a simplified form of 6 over 15, you could have put it in the calculator and simplified it. 2 over 5. Same thing. Does not matter. You would get the same answer. All right. So the next one, they said, in the first month, he will teach his class 20 times. So now we're talking about how many times he teaches the class. So now we're moving from the probability that he's going to pick a female student to the probability that of his classes, okay, out of the classes that he teaches. So we're dealing with binomial probability here. So if it says here, what's the probability that he's going to choose a female student 8 times? So we're going to find the probability that X is going to be equal to 8, and we're going to be focusing on the female. So when I do binomial probability in the calculator, I'm going to do the binomial PDF. So I go to second vars and I go to binomial PDF because I'm looking at a specific value or a particular value. So we know that the number of trials is the number of times he's going to teach his class, so that's 20. The probability that he's going to pick a female is 0.4. Or you can put the fraction of 6 over 15 or 2 over 5. And then we're looking for him, it says 8 times. So we're looking for, he's going to pick a female 8 classes. So when I do that, I put that in, we end up getting 0.18 in 3 sig fig. Okay. So when you write it on your work, you want to tell them what you actually put in. So I'm going to put that my trials was 20. My probability was 0.4. And then my X value, let me make sure I'm writing everything that I put in the calculator. My X value was 8. So, and I see that my probability ended up being 0.180. Remember, this is 3C Fig. If you want to write your answer out, write it out. So part C, it says find the probability that he will choose a male student at most 9 times. So when I say at most 9 times, I'm saying 9 times or less. So the probability that he's going to pick a male less than or equal to 9. So because I have a range of values, I know that instead of using binomial PDF, I'm going to be using binomial CDF, cumulative. All right, so I go to second bars. I go to binomial CDF. Oops, and let me close out of all that all the way. Go to binomial CDF here. The number of trials, we already know the trials is going to be 20 because that's how many times he's going to teach his class. Then I know the probability that he will pick a male is going to be the opposite of a female, which is going to be 0.6. Or if you wanted to, you could say 9 over 15. And then we want to know the X value. So remember, when you do CDF, you have to understand that it does the X values for that value or less. So I know that my X value here is going to be 9 because it's going to be 9 or less. All right, now if it says less than 9 times, then you will have to put an 8 for the X value because it will be 8 or less. You don't want to include the 9. All right, so when we do that, we see that our probability that X is going to be less than or equal to 9 is going to be approximately 0.128 in 3C Fig. So that is my answer for part C. All right. Now let's look at number 14. Number 14 says that Ollie has installed security lights on the side of his house that are activated by a sensor. The sensor is located at point C, which is directly above point D. And the area covered by the sensor is shown by the shaded region enclosed by triangle ABC. The distance from A to B is 4.5 meters, and the distance from B to C is 6 meters. The angle ACB is 15 degrees. They have already put this information on the graph for you, so you don't have to write it in. They want us to find the angle CAB. So for the first question, they want us to find angle CAB. So if I go from C to A to B, the angle that they want me to find is here. So this is my theta. So for part A, if I find angle CAB, the first thing I should understand here is that that shaded region, that triangle ABC, is not a right triangle. Anytime we do not have a right triangle, we cannot use sine, cosine, and tangent. We cannot use the Pythagorean theorem. We can use the law of sines or the law of cosines. So when we use the law of sines and law of cosines, always try to use the law of sines first because it's easier. So the law of sines basically just says that you have to have the sine of one angle divided by the side across from it is equal to the sine of another angle divided by the side across from that. So as you can see here, I have the angle 15 degrees and I have the side across from it, which is 4.5. So I'm going to have sine of 15 divided by 4.5. That's going to be equal to the sine of angle CAB, which is basically the sine of theta. And that's going to be divided by 6. So, of course, I cross multiply. So I'm going to have 6 sine of 15 is equal to 4.5 sine of theta. And then I'm going to divide both sides by 4.5. So that's going to be 6 sine of 15 divided by 4.5 is equal to the sine of theta. From there, we need to take the sine inverse. So I'm going to hit second sine for the sine inverse. And I'm going to type in that fraction. So that's going to be 6 sine of 15 over 4.5. And always make sure your calculator is in degree mode. As you can see, if I look at the top of mine, it's in radians. So I need to go to mode. And I need to go to degree. Turn it on. And then I can go back and recalculate it. And as you can see, I get that my angle is approximately 20.2 degrees. So that is the angle CAB, right? So that is my answer there. Of course, when I find this answer, I'm going to go back on the picture and I'm going to write it in because I may end up needing it again. So that's going to be 20.2 degrees. Next, for part B, it says point B on the ground is 5 meters from point E at the entrance to Ollie's house. So E is the entrance, and we know that from point B to E is 5 meters. It says he is 1.8 meters tall and is standing at point D. Okay, so I know that Ollie is 1.8 meters tall. So if I kind of approximate, I would say based off the other measurements given or the other links in this picture, I would say 1.8 is approximately like somewhere about here. And I know that this is his height. So it's saying that what's happening is he's going to walk towards the sensor, and we want to figure out when he first activates the sensor. So let's say if he is this tall here, I'm going to draw this in and I'm going to move it so you can see what I mean. If he is this tall, as a matter of fact, let me draw a little stick figure. And we're trying to see when he first activates the sensor, he's walking towards it here. Okay, so as he's walking towards the sensor, the very first time that his head or his feet cross that line there, that's when the sensor is going to be activated here. Okay, so we're basically creating a right triangle with his body, okay, so to speak. All right, so if I know that he is walking towards it, then basically if I know that I'm creating a triangle with his height, then that means that what I'm trying to figure out is from B to D, and I'm going to draw this out so that you can kind of see what's going on here. So we're going to have B to whatever point that is that he is tall. Okay, so here we're going to have B here. We don't know what the name of that point is, but we know that this is going to be 1.8 meters here. And we can find the angle. So one thing that we should be looking at is the fact that this non-right triangle, if we subtract those two angles from 180, we should get the third angle. So if I do 180 subtract 20.2 minus 15, that's going to give me that this angle here in purple is 144.8 degrees. And then if I do 180 subtract 144.8, that is going to end up giving me that this angle here on the other side of it is 35.2 degrees. So I already know that this angle in this picture that I drew is going to be 35.2 degrees. So because I know that that is 5.2 degrees, what I am basically trying to find here is the distance between where he is and the distance between B. Okay. And if you wanted to, I could have called the point that he was actually standing at when he activated it. I could have called it X, if you will, which technically I've said that the distance was going to be X. So here, if I find this value here, if I'm going to use my trig, I have opposite and adjacent, so I will be using tan. So I will basically say the tangent of 35.2 is going to be equal to 18 over x. And I know that if I multiply, I'm going to have x times the tangent of 35.2 is equal to 18. And then I will have to divide by tangent of 35.2. So if I have 18 divided by tangent of 35.2, I will end up getting that x is approximately 25.5. So that's how far he would be. And that should be 1.8, not 18. And that's just going to be 22.55, excuse me. But remember, they said that the distance from point B to the entrance E of his house is 5. So if I want to figure out how far he will be from his house, then that means that I would need to basically see, and I will put here, I'm going to draw where that 2.55 is. So that 2.55 is a little bit over half. So I would say halfway, so is approximately maybe right here. All right, so that's approximately 2.55. All right, so I can say here, now that I found that, because I know that this is 1.8 meters, I would know that this is 2.55 here. So if I want to figure out how far he actually is from the entrance of his house, I would just finalize and I would just say, okay, that just means that I'm taking 5, subtract how far he is from the from B, and that will end up giving me 2.45. So that is how far he is from the house, right? And we know that we are talking about meters here. So our answer is 2.45. All right, so that is the end of the specimen paper 1. So if you need, or if you have any questions, you need extra assistance, please let me know, and I'll be more than happy to help you. Have a great day.